pace at which the enemy adapted their tactics and their technology meant that we couldn't rely on our old processes anymore. The cost of deploying remote controlled precision strike capabilities is lower than we could ever imagine it before. And now we have to react to that precision strike at the exact same pace that they're iterating. Target acquisition can become overwhelming for operators because they're consuming information from many different sensors. The autonomy is handling two major parts of the kill chain. One is target acquisition, and the second part is the target engagement. If you're trying to deploy a new piece of equipment, they have no time to gain experience with the system. They don't have any way to trust it. You have to unnaturally force it into position so that it's ready when the time of need comes.
Hey everyone, and thanks for listening to another episode of DIB Innovators. I'm Dave Graff, and today I'm joined by Bryan Bockmon, CEO at AimLock. Bryan spent more than 2 decades working at the intersection of physics, robotics, autonomy, weapon system, from Los Alamos to applied research labs to building an autonomous targeting system used on the battlefield. Bryan, great to have you.
Yeah, thanks for having me. Pleasure to be here.
All right, well, you've got a really cool background, so before we get into it, take us back to the beginning. How did you start your career and what pulled you towards, deep technical hardware-driven problems?
Yeah, absolutely. I think I've probably always been an engineer at heart, even when I was a young kid. Fascinated with machinery, loved solving problems. Although you know how it always starts, you've got the knack. You create more problems than you solve as a kid. But as that interest area focused in, I found that robotics and all of the benefits that can come from that man-machine interface became sort of a passion project, and that intersected with real life just fine. So that led to the transition from the academic world over to S&T, and then S&T introduced me to the entire world of defense.
Right, and so and talking a little about each one of those steps, what did you do and kind of what took you to the next one?
Yeah, well, I studied mechanical engineering at Texas Tech University. There are many different pathways that mechanical engineers can take. Everyone specializes in something. That way they can create practical benefit for the world. But in my case, I was a thermodynamics guy, and that opened up opportunities to get into defense research because there's a scale from fundamental research all the way up to applied research that gets developed at national laboratories, at Department of Defense laboratories. All of these components sit on a low technical readiness level scale. Like the science exists, we have some ideas and understanding about what we're going to do with that technology. And then it's up to test engineers to document it and figure out what we can do with it next. So yeah, I wound up at Los Alamos National Lab, which is one of our nuclear weapons laboratories. There's all kinds of missions that you have there. You've got life extension programs for nuclear systems, and then all of the tests and engineering that goes along with trying to make them into useful products for the nation. So I became an experimentalist and spent several years in grad school and there at the lab trying to create value out of that. And I happened to be there when 9/11 happened. So you get torn when you're in a situation like that where you're trying to serve a national security mission, and then there's pressing issues tactically at hand as well. And so that's why I decided to leave the government. I jumped into private industry, and then I started working my way up the technical readiness level scale and did applied research after that. Of course, for that entire decade, many of us who were in science and technology were focused on counter IED. So that's threat assessments, that's all kinds of protection, force protection studies, equipment, everything that goes along with that, just trying to support from the periphery as much as we could.
Yeah, very cool. And then that led to kind of autonomous targeting now that was...
Yeah, it's actually quite a jump. That everything ebbs and flows in current events, in industry, in government. And at the end of the first decade of the 2000s, as GWAT was reaching sort of an ebb in its pace, it gave everyone a chance to reset their mind. Active duty guys who were burned out were moving on to the next stage of life. People who had worked counter IED world were looking for the next technical problem that needed to be solved. And that gave me a chance to figure out what was next. And so in my case, that meant I'm going to launch out on my own, start a small business, and co-founded a research laboratory, which allowed us to take bits and pieces of technology stacks. serve government customers with that tech stack, and then simultaneously convert it into products that could eventually be deployed to the battlefield. So from like 2009 to 2014, focused entirely still in the applied research world, but was incubating everything that eventually became AimLock and autonomous targeting, which led to 2014 founded AimLock expressly to productize and mature all kinds of autonomous target acquisition and target engagement systems. That's what led to where we are now.
Very cool. And so I come from my background flying. Autonomy, especially back then, did not necessarily resonate with everyone.
It's true.
Or it means different things to different people depending on where you're sitting.
Yeah, absolutely. Yeah, there's the public awareness of autonomy, and then you've got engineering technical definitions of autonomy, and then there's policy discussions, and the intersection of all of that is how we actually get it done.
Yeah. Do you think it's still, I mean, it was controversial and now it's, I'd say, unavoidable. How do you see that? What changed, that really kind of moved the perspective?
Yeah, for sure. I mean, if you start with the context of the technical definitions, autonomy is really just an assembly of automation systems. We're all familiar with it in our everyday commutes now because cars have automated systems. They've always had automated engine management systems and anti-lock brakes. That's decades old technology. Now we're getting familiar with the automated lane holding and automated emergency braking. Each one of those steps is just one thing that a human operator used to have to think about intensely, especially when we're reacting to an emergency circumstance. And now we've got these man-machine interfaces in our cars that help us immediately react to whatever that need is. That analogy carries over perfectly to other mission sets as well. It's just we're automating a different step. And so from an engineering standpoint, it's just this natural, continuous progression. But the policymakers, they see it entirely differently. They're deeply aware of the difficult ethical implications, and really the public instantly jumps to fully autonomous everything because it's hyper sensationalized in the media. But in reality, the policymakers have been tracking really well. It was probably 15 years ago that the DoD really started handling it well, and now we've got mature policy that understands the nuance between the two extremes. So the policy allows for us to do the right kind of technology building, the right kind of experimentation, but it also makes sure that we have the right safeguards, the right kind of oversight before you allow automated processes to get you into an ethical problem.
Well, obviously come from the labs, then small business, starting your own company, getting into another one, incubating AimLock. Why is it, just your conceptual perspective, or not even conceptual, of small businesses are so much better at innovating than like the large primes?
Yeah, there's a really interesting set of push and pull that's available in any given situation. If you take a look at the large primes, they're a lot like a government bureaucracy. They exist to accomplish these monstrously large projects, which are complex, immensely time consuming. And so the organizations are set up to handle the complexity and the time and all the expertise that's required there. So that's the benefit that we get from bureaucracies and big organizations. On the other hand, there's some baggage that comes along with that. Once you've built up decades of experience and you have all kinds of programs, billions of dollars of contracts, taking a risk has a huge penalty. There's no such thing as making a mistake, hurting your reputation, and then being able to restart from something that's so large. But when we're operating in a small business environment, it's entirely different. We can make a mistake, we can learn from it, immediately build something better. And that iterative cycle is so fast that we don't even have to worry about it. It's literally, this is the thing we're doing. And then the next thing we're going to do is either going to succeed or fail related to that. And that gives us freedom that they don't have. Now, of course, we can't take on giant projects, immense complexity. We have to collaborate to get all that done. But that's kind of the beauty of building different kinds of teams.
How do you think the acquisition slash accessibility of private capital has changed that?
Well, yeah, it creates really interesting tiers of capability because if you think about two extremes, one extreme being We're going to follow the old-fashioned processes. We're going to use the bureaucracy to do something complex. You got to have a requirements process, and that's going to instantly create like a 9-year roadmap to get from inception to initial operational capability. That makes sense for some stuff. And on the other hand, you have the extremes where you get private capital, funding, dual use technology. Everybody hopes that the investments are going to pay off and we're going to be able to pay back all those investments. Sometimes it works, sometimes it doesn't, but it has challenges of its own because it ties you to a commercial market. There's probably a spectrum of in between these two extremes where all kinds of new opportunities are going to be discovered now that these are both functioning pretty well, if we can keep the balance.
Yeah. How did you, if you don't mind me asking, how have you capitalized AimLock?
Well, AimLock's a blend of private investment and government contract funding. Some of the government contract is funding testing and evaluation. So that's a great way for government agencies to become a partner to small business. Because small business can take a risk. We can prototype technology. And that prototype technology, we may never be able to get enough capital to carry it through to fully certified, deployable tech without the government partners. So there have been many years of really loyal government partners who said, hey, we find value in what you're doing, and we think we have a place for it in the modern battlefield. And so we're going to fund that kind of crossing the gap by paying for that testing and evaluation and certification.
Yeah, do you think that works better than, well, did they do that through Sivers or were that?
Not in our case, because we're specifically working on the kill chain. There's a huge interplay between sensors, lethality, and in our case, what created value the best were the OTAs, the other transaction authorities. That's an old, all right. DARPA was really the organization that initialized this capability to procure prototyping for the purposes of testing without all of the other federal acquisition regulations being applied instantly. That, relieved the burden of a lot of the acquisition slowdown. And it also allowed us to operate faster and more flexibly than we would in the CIBR and SCTR environment. It was a perfect sweet spot for where we were and the work we were doing.
So that leads us into kind of battlefield realities with today's requirements. Obviously, we've gone through, Ukraine, Israel, Iran. We had the war on terror. It's given real-time feedback loop for folks that it can get involved. You'd see that shaping, innovation in small companies like you.
Well, the one thing we know for sure is that the pace at which adversaries can react to any capability we deploy is just unprecedented. If you look, the same thing happened with the IED problem. We had IEDs have been around for many, many decades, but the pace at which the enemy adapted their tactics and their technology meant that we couldn't rely on our old processes anymore. We had to instantly adapt the counter IED processes. Then that carries over now into the modern battlefield where the cost of deploying remote controlled precision strike capabilities is lower than we could ever imagine it before. So now these proliferate across almost every battlefield. And that's basically an economic driver. The technology became so ubiquitous that no one had to raise millions of dollars to be able to deploy precision strike. And now we have to react to that precision strike at the exact same pace that they're iterating.
So how do you see this? I haven't asked anyone this yet, but when we look at like weapons, we're going to not need a gun in an airplane anymore because we have these missiles, and then the defense counters the missiles, so now we need the gun again, and back and forth. So as you look at this, we're going to spend billions upon billions of dollars on drones, right, to bring that threat to the adversary. Adversary probably doing the same thing. We also have some pretty damn good counter drone capabilities, which we can talk about a little bit where you fit in that. But often, I foresee a future where that's significantly going to limit the ability of drones. Now, we'll have drone defenses everywhere, but they'll be less invasive, they'll be less destructive, they'll be more managed, and then we'll be right back to where we were. Big platforms, big war.
I think that you'll hear a lot of theories put forth that we can handle this through commercial dual-use technology, and that's going to lower the price, and we're going to be able to do everything with that. I think you're completely wrong with that. Other people say, that the exquisite systems are unaffordable and will never be able to sustain them. I think they're completely wrong with that theory too. In reality, just like this is true kind of in every other part of life, there's a spectrum of solutions from extremely exquisite and expensive to extremely affordable where we can proliferate everywhere. And in between there, we're going to have all the other practical solutions. So my take on it is that in order to get this done properly without running out of money, we're going to have to build modules that can be repurposed because we can't afford to have a gun or an ammunition set for every problem. We're going to have some general purpose, and then that's going to overlap with the next layer. The same thing is true with cameras and radar and fire control computers and mobility platforms. Each of these things are going to have to exist on a spectrum. And then our commanders and our acquisitions executives are going to have to decide how much should we invest in each layer to make sure we've got a nice holistic approach to this problem. Because you're right, it's going to evolve and change all the time. We'll go back and forth and back and forth.
Well, that takes us to AimLock. You guys operate a very specific point in the kill chain. Talk to me about AimLock and where Autonomy is basically, beating the trigger, if you will.
Yeah, absolutely. So we're fire control system specialists, and that's technical jargon for the systems that point the weapons where they're supposed to go. But the practical benefit to the warfighter these days is that they will be able to achieve speed, accuracy, and standoff that they haven't been able to before. The speed, because the autonomy is handling two major parts of the kill chain. One is target acquisition, and the second part is the target engagement. In between there, you still have human operator observation and decision making involved in the kill decision. But the two really complicated, like target acquisition, can become overwhelming for operators because they're consuming information from many different sensors, networks, things like that. So we build fire control systems that consume all of that sensor data and distill it to the actionable intelligence. Then once the operator makes a decision, yes, I need to defend my area, or yes, I need to strike that target, then it immediately rolls over into automated target engagement, which is maybe some days we're directing machine gun fire. In counter US world, we do direct fire gun systems, which provide a short range air defense. It's literally like World War II in Korea all over again, because we've got short range air defense gun systems. Their benefit, low cost per engagement, and we can manufacture thousands of them without bankrupting the defense industrial base. They fit specifically in that layer. So it's not last line of defense like shoulder fired shotguns like you see in the media these days, but it's also not long range defense. Whenever we have an opportunity to deploy other type weapons like short range interceptor missiles or interceptor drones, our autonomy can deploy those weapons too. So we build it as a modular system that will never grow obsolete because we can rotate out sensors, we can rotate out effectors until the end of time.
So specifically, you're building a targeting mod. What do you got?
Yeah, absolutely. The core targeting module is called Keystone as a product name, and it links everything together. Some days we only have one or two cameras available, and that's a normal circumstance especially for a remote controlled system. If we're on a unmanned aerial system, we may not be able to carry very many sensors, and so limited data, limited amount of payload capacity for an effector. The Keystone can use that, and then the very next day, it's consuming something off a huge centralized command and control network.
So how is that, explain to listeners, how is that different than, I'd say, current weapon systems?
Current weapon systems are single-purpose machines, meaning they are intended to fight in some form of traditional doctrine, some traditional fighting doctrine. In the future, remote control systems and autonomy at the edge allows us to rewrite fighting doctrine. And we don't have to throw away any of our existing tactics, but now we have access to entirely different tactics. So a dismounted group of soldiers can now carry huge amounts of ammunition or supplies or sensors on unmanned ground vehicles, and they get an entirely new capability that was previously reserved for some mechanized unit. The same is true across basically any domain.
So is this a platform, a vehicle, a radar dish?
No, it's interesting that you describe it that way. Yeah, I think I say that the new platform is the network because the network is what we hang all other capabilities onto now. But the Keystone is an edge computing device. It's just specialized for the performance and the security that's required for lethal systems.
So it's more of a box, if you will, that contains
Absolutely.
the leading edge, and you'll put it next to a gun system.
Right. Yeah, when we marry these up to remote weapon stations, they become short range air defense systems or short range surface defense systems, depending on if you're working in a land environment or a surface environment. Most people have seen a CWIS or a CRAM on at least on the news. And so you may not understand how all that laces together, but you've got radar sensors for early warning for incoming threat. All of that's fused together into a firing solution for the cannon that's mounted on those large systems. And then the timing of those shots fired is timed perfectly to minimize the threat to ground forces while maximizing that engagement probability. That's a perfect layer. Like at sea, you get this, let's call it 500 to 2,500 meter layer of defense around any kind of critical asset. Same thing is true around a major base on land forces. Now, what is difficult about those type systems is that they're still quite expensive and it's hard to pre-deploy huge infrastructure like that everywhere that you need it. Every little fob, every tier 2, tier 3, tier 4 asset in a hierarchy of military assets, really difficult to put that kind of power, weight, ammunition, the staff that's required to operate those systems. All that stuff is complicated. So when we build a modular small system, now we can make hundreds or even thousands of these units at dramatically lower costs because the software, the computing, the network interfaces, they're all standardized now. Those standardization procedures and policies allow us to share safety reviews. We share technology development that lowers the cost across the board. And now we have a new tool that we can deploy everywhere at a far lower budget.
So if you have a small, let's say, short range missile battery, normally right now, the way that would be delivered is it has all this built in, right?
That's right.
And so now they could
Exquisite radar, everything.
yeah, now they just put the battery, if you will, out there. And then somewhere there's got to be some fusing of some sensors, and it pulls it all in. And then you could do that with, you know, a rail gun or,
Absolutely. Yeah, you already have command and control systems that integrate some of these things together, but not everywhere, not all the time. And if you have interrupted communications from your major C2 systems out to your effectors, you're reliant entirely upon the edge computing system and a few operators who are there on the edge.
and so how does that change the, like, because they're still got, if you're remotely doing this,
Mhm.
you're half a mile away, whatever. We'll use clicks because that's what Army guys use.
Yeah.
You still have to have the comms, right? Or are you saying that that comms can be cut off, and since it's edge computing, if it's on autonomous mode, it can just go? Or
A lot of it depends on two things: policy and trust. So if we've had sufficient time to experiment with these autonomous systems, then the commander who's choosing to take on this risk can say, I've seen the test results. I know how much of this autonomy can be trusted to operate in a decentralized manner. And I'm going to give it that tiny slice of operating authority. On the other hand, if you're going fast and you're taking on a lot of risk, you would say, I'm not going to allow any autonomous actions, even defensive actions where the risk of collateral damage is low, because I haven't yet had time to develop the trust between the man machine interface.
where do you find that trust in the systems you're building? The fire control system. Where does that happen? Tend to break down?
It tends to break down when the schedules are tightly compressed, right? So if you're trying to deploy a new piece of equipment and everyone who's deploying with it is under a tight training schedule, it's already full. They have no time to gain experience with the system. They don't have any way to trust it. And in those difficult circumstances, you only come to trust it when you're in an emergency state. Because when you're in an emergency state, you'll use anything that might help. That can build trust right away.
Very cool. And if you look at, so is this being, are you out in the field now? Are you being utilized?
Yeah, they're high technical readiness level versions of this autonomy, and they're in all kinds of experimental programs. We've already passed a few combat evaluations. Obviously, we're not at liberty to disclose how and where and who all of those involve, but it'll eventually become revealed as they achieve specific milestones in combat relevance.
Wouldn't this be, I mean, does it require then the buyer to go, look, I want modularity? Otherwise you're just going to buy the system, because it's been tested, it's been used. How hard is that transition to get the institution, if you will, to think this way? Are you seeing traction in that, or is that?
Oh yeah, yeah, throughout these, even in a bureaucracy, there are people who think about this problem clearly. They care about getting capability of the warfighter, and they understand the constraints that all the different organizations are under. Acquisition organizations, funding organizations, policy, safety. Everyone's got constraints that they're trying to work with. What we find is really beneficial is when we find people who are aligned on the mission with us, and then they help us find ways through the gauntlet. And we see that all over the place. Really, really well-intentioned people.
Yeah, that's encouraging. I mean, it's hard. How is your, since it's remote, you can do remote. I mean, I guess
Yep.
that's one big, you know, value props you give, right?
Right.
Sit there. Talk to me about comm linkage. Like how, I mean, not specifically the technology behind it, but is like denied comms area, are you at higher risk, lower risk than the unit that's self-contained that can do all this on its own by this modular perspective?
Yeah, we strive to make sure that the operators can seamlessly switch back and forth between a permissive operating environment and a really degraded operating environment. So when you're in a permissive environment and you've got this perfect comms link between the effects and your control point, you've got really high quality video, instantaneous feedback to do any part of the mission that you need. And that's an ideal kind of GWAT-esque environment. On the other hand, when everything's degraded, you the machine now has to become tolerant of intermittent communication back with the operator. And the operator now is looking for those perfect touch points with the machine to say, are you where you need to be at the right time? Are you seeing the things you need to see? Do we still have good situational awareness? Now you're down to tiny little bits of data that are flowing back on the data link whenever it's necessary.
Are you connected by wires? Are you connected by fiber? Are you connected through, different signals?
All of the above. Yeah,
Mhm.
you have to be able to interchange those mechanisms depending on the operating theater.
Do you find that your CTM, do you call it CTM?
What do you call it? The Keystone?
Oh, the Keystone. Can you put it on like drones, for example?
Absolutely. Yeah, when you put a Keystone onto drones, you see two immediate benefits. Number one, the Keystone can manage ISR payloads, laser target designators, and things like that in a way that can interact directly with the C2 system. So you may have a local drone controller and a local ISR controller. Maybe they have good comms with the drone, maybe they don't. But now the network becomes the ecosystem that everyone can work through. And it doesn't require that you have perfect connectivity on every leg of the network all the time because the Keystone can step in and handle some of the functions. Like I need to fly to a certain place. I need to look at a specific area. I need to identify targets in that area. And maybe I even need to activate a designator to make sure that we've synchronized with some other organization.
And so, how did you come up with this idea, though? I mean, what were you working on?
So when I was working counter IED, I got involved in EOD robotics, and I realized that the cognitive load to operate EOD robotics is off the charts. Super intense. You're under fire or you're at risk when you're operating in these environments. Secondly, the every single operation, think back circa 2004, every single operation was manual. There was no autonomy in the EOD robotics. Then you had very complicated ingress and egress routes from your operational area to the area of the threat. And while we were working in this environment, basically supporting EOD services, I was still paying attention to my academic research world. And that's how I married up computer vision, which was still very academic at that time, with robotic automation. And I thought, hey, There's absolutely no reason why an EOD technician should be manually performing all of these functions when the ingress and egress could be completely automated. And of course, as an engineer, you start marrying up available technology to problem sets that have severe need. Like lowering cognitive load is a severe need for combat environments. So it's a great place to apply technology to serve the need. And then from there, it really is a process of elimination to figure out what's the greatest need. Does that need already have recognition among the end user groups? If it does, the next step is to figure out, do the program offices know that that need exists? Because they don't always have the ability to automatically function properly. And then the last step is to align with funding priorities from acquisition organizations. That's kind of the recipe to get this job done. When you recognize a need and you know there's technology, we call it the technology push solution. I have technology, I'm pushing it into a need. The requirements process is the opposite. It's technology pull. I recognize that I'm an operator and I have a need, and I'm asking to pull technology in to serve the need. Both of those things happen all the time.
Talking about your journey of starting up kind of two companies, in the defense space, and how are they different? What are the big lessons learned out of this?
Yeah, absolutely. Yeah, the first business was it is still a successful services provider. So we have technical specialties offered, basically subject matter expertise offered up at a speed that the government labs and the primes don't match, right? That's the value proposition for the first business. There are many, many, many customers across the DoD enterprise that need that kind of service. We're basically we're removing obstacles to getting information quickly. So that's a laboratory research kind of an environment. AimLock, on the other hand, is all about taking nascent technology, which it was when we founded the company, and making sure that it's accelerated to the battlefield as fast as humanly possible. Because there are hundreds of other problems along the way that would not allow this to happen naturally. So you have to unnaturally force it into position so that it's ready when the time of need comes. And that's what's happened here. The time of need came only in the last couple of years where the world is aware of the threat because it's become so visible. The money to fund solutions is now available because people's lives are in danger. If we had not started the technology development journey 10 years ago, there's no way it would have been ready to deploy right away.
It's fascinating how timing works, right?
Absolutely. Yeah, there's no doubt it's the most critical element in most solution success stories.
Yeah, I mean, because there is no bigger need right now than the counter drone and that capability set as we're seeing everywhere.
Right.
Awesome. So 10 years from now, what do you think the relationship between the warfighter and autonomous systems looks like?
Well, we have no way of predicting the economic conditions that are going to dominate all of this. But if you just assume that economic stability is going to be reasonable, then from a technological standpoint, we can confidently state that the interfaces are going to be smoother. So right now, things are always a little clunky. We've got training element for humans that's complicated because every human's different, and so no training pipeline works on everyone. Same thing's true for machines. When we set up machines, we can set them up to work in certain number of environments smoothly. Now we're trying to figure out how can we automate this merge so that machines and humans can easily understand each other. Like right now, a lot of control is through tactile control. You've got joysticks and you've got buttons and you have displays. Every year we see improvements in that interface. So we're not always relying upon touchscreens. We're not always relying upon joysticks and buttons. And it's becoming easier and easier to train. And it's becoming easier and easier to get the machines to perform in various environments. That's the biggest impact that AI/ML has had in robotics development because our training costs now for machines are tremendously lower than they were a decade ago.
How do you think Neuralink's going to change things?
I hope, you know what? I hope that we find many, many ways to connect with the machine control without having those permanent surgeries required.
A little terrifying. That probably some great use cases where people have no other options.
No doubt.
Awesome. Well, I'm going to go through lightning round here. Just give me your quick thoughts. What's the biggest myth about selling to the DOW?
There are probably two big myths. The biggest one right now is that commercial dual use technology is going to solve all of the DOW's problems at low cost, because it definitely won't. There are many unrepresented costs and deficiencies associated with that idea. The other one is that the requirements based process is going to work ever again. I think it never will again.
Yeah, I agree with that. Hardest lesson in building a defense company?
I think the hardest lesson is what we spoke about earlier with regard to timing being the most important part. I see many, many really intelligent, really dedicated people create amazing technical success, and they understand the battlefield, but the conditions aren't right to allow them to fulfill the need right now. That's just a sort of a natural condition of the world that I've had to learn how to accept.
Well, I mean, I am going to sidebar on this. What if we hadn't had these conflicts? Where would you be? Like, how different would it be?
Yeah, the technology developments would not be needed, and they would not be recognized as valuable, and they never would be until the wider world became aware of it.
Yeah, I'd like sidebar more, but I won't. Okay, sacred cow and defense tech that would be proven false.
Oh, I'm gonna go with the dual use technology.
And what do you think the biggest opportunity in defense is right now?
I'm totally biased. It's gonna be robotics. General purpose robotics, in fact. The I think special purpose robotics is now obsolete, and general purpose robotics allows us to adapt to whatever the circumstances are.
So give me an example. Like, what would the robotics look like?
So in our case, you think about a special purpose robotics would be an auto loader for an artillery system. That's one robot that does one thing. It rapidly reloads that howitzer. On the other hand, if we have general purpose robotics built into our ground systems, now we'll be able to load and unload supplies. We'll be able to do casevac, and that system, that loading system, now has two purposes. There may be 10 more that can be achieved as the operators gain access to it. And with AIML, now they can say, "Hey, I've got a brand new mission. I want you to do this mission." And then in the field, they'll be able to train the general purpose robotic system to achieve or to collaborate on that mission.
What do you think the shape will look like for general purpose? Will it be humanoid?
The one real huge benefit of humanoid robotics is that the entire world is designed around our bodies anyway. So the humanoid robotics will be able to replicate many of the things that we do now. That means they'll be able to use legacy machines in a similar way that we use them. That's really promising.
Yeah, this is great perspective. Well, Brian, it's a great conversation. Thanks for breaking down technology and what autonomy is going to look like. I think you guys have something really cool going there. If people are interested in following you, how would they do that?
Yeah, aim-lock.com. That's an overview of all of our products and our work. And then we post whatever we can post onto LinkedIn after that.
Perfect. Well, thanks for listening, Div Innovators. Thanks for being a guest, and I look forward to joining up.
My pleasure.